All right, so in section 2, we're going to get into working with exponents and scientific notation, and we're going to kind of do a little bit of review of some of these exponent rules that you've learned before. So when you're multiplying items that have terms that are raised to powers, and you're maybe doing multiplication, dividing, adding, subtracting, like those kind of things, there's specific rules that apply to the exponents and how to work with them. Like I said, a lot of this should hopefully be review because I know we went over this stuff last year in Algebra 2 as well. But the product rule, we're going to start there, says that when you're multiplying exponential expressions, if they have the same base, and the same base would mean they have the same, like they're both numbers, or they're both like the letter A or the letter B or the letter X. If they have the same base, then you can add your exponents together. So they're showing that to you here symbolically. B and B would be considered your bases, and they're both separately raised to different exponents here. In order to simplify this, you would just add your exponents. So we're going to do that on this example here. I would just maybe look to see what's similar. So we do have a couple of just plain numbers, 4 and 10. So you're just going to multiply those like you've done before. So that becomes 40. Then I have an x to the third and an x squared. So if you add those exponents, what do you get? Good, x to the fifth. And then for my y's, I have y to the fourth and y to the sixth, so it becomes y to the 10th. Good. So when you're multiplying, you add. When you're dividing, you do the opposite and you subtract your exponents instead. So if it's written like a fraction, or if it has a division symbol in it, switch your rule to subtracting your exponents instead. Okay, so you can kind of see that down here. They've got that rule written out. Again, notice that you can only do this with the same bases. So you can't do this if like the top is an X and the bottom is a Y. They have to be the same base in order to do this rule. Just like before, if you have regular numbers, just divide like normal. What's 27 divided by 3? 9. Okay, now my X's, what's 14 minus 3? Good, 11. And what's 8 minus 11? Good, negative 3. Now we haven't talked about this yet, but maybe you remember from last year, are we allowed to keep negative exponents? No. What should we do to fix this? Put it on the bottom. Because right now, if you think about this, guys, everything is over a 1 at the moment. Like there is no fraction in the problem. So we're going to take just the one that's negative and move that down to the bottom. You'd only do that if it's negative. What would have happened if I had a fraction and the negative exponent was in the denominator? Where should it go? To the numerator. It just goes up top instead. So you only move the ones that are negative. I would say the biggest mistake I see with that is if it's a positive exponent and you're moving a negative one. Some kids think you got to switch it all. You only switch the ones when they're negative. Okay. Sometimes you'll have things raised to the 0 power, and we have a special rule for that. So the 0 exponent rule says anything raised to the 0 power is just 1. Sometimes they'll give you a problem like this first one where everything is raised to the 0 power. So all of this, really what's happening is the 0 is applying to all of these exponents on the inside there. Well, if you multiply anything by a 0, it's just 0. So the 125 gets raised to the 0 power, the x gets raised to the 0 power, and the y does too. Now, I don't actually have to show all of that. I just want you guys to understand if you see that the entire quantity is raised to the 0 power, your answer is just going to be 1. Sometimes they'll sneak that in there to see if you're paying attention. Now, if you look at the second one, not everything is raised to the 0 power. What is, though? Just the x. So really, I'm just going to cross the x off because it's going to be a 1 now. If I multiply by 1, it doesn't change anything. What am I left with then? Yeah. So watch that. Just because they throw a 0 in doesn't mean that everything becomes a 1, only if it's on the outside of the parentheses. So just be like mindful of where are they putting that 0 at. Okay, that negative rule, we talked about this a little bit already. But anytime you have a negative exponent, we can't leave it there. We want our exponents to be positive numbers. And so if we need to, we will flip things around in fractional form in order to write that negative exponent. And we talked about this already, but if it was in the denominator, then it gets moved up to the top of your fraction. Again, only move things that are negative. So if you look at this first example, which is the one that's causing the problem? Yeah, just the x is. So I'm going to need a fraction. What am I going to have on top?
3y to the 4.
Good. And then that x to the 6 is now just going to go to the bottom and become positive. But something that I see kids do for whatever reason, I don't know why, even though we talk about it, I'll still see some students will want to put that 3 on the bottom for some reason. If it's not negative, like raised to the negative exponent, then don't move it. Even if it was like a negative 3, a negative number is fine. A negative exponent is not. So that's kind of the difference that you need to be aware of here. Now, this next one, I know it's really tiny in your notes. I don't know why. What do we need to fix?
The negative 3 in the numerator and the denominator.
Yeah. Yep. So what am I going to keep on the top? The 5. And yeah, the y's got to come up. So that becomes y to the 5th. Okay, so that takes care of the 5. That takes care of the y. What's going to be on my bottom then?
X to the 3rd.
Yep, and good. So yeah, really the x and the y just kind of switch positions there. Questions on how we work with those negative exponents? Okay, we're just kind of zipping through these here real quick. The next one is called the power rule. This is different than the product rule. The product rule is the one we started out with where you're multiplying terms, so they're all like individual. The power of a power rule involves grouping symbols of some sort, and there's things with exponents on the inside, and there's an exponent on the outside. Kind of like what we saw up here. This one is demonstrating the power rule because that 0 exponent is going to apply to everything on the inside. When you have something that is already raised to a power, and then on the outside of your grouping symbols, there's another exponent. Instead of adding, like we were doing when we were just multiplying bases, we have to actually multiply the exponents together. Think of it too as if there's lots of terms inside of your parentheses, you're basically distributing that exponent into everything that's on the inside. So, like on this one, this 3 that's on the outside is going to go to the x, but it's also going to go to the negative 3. So now I have, if I really were to write this out, negative 3 is being raised to the 3rd power. And then x, you're going to take 5 times 3. What is negative 3 raised to the 3rd? Good, negative 27. Good, x to the 15th. And then we leave it, okay? You don't need to do anything with the negative 27. It's not a negative exponent, it's just a negative number, so we're done. Okay, so that is when it's maybe all just one quantity, but what happens when we start to have like division happening in our problems and then they're also applying the powers rule? So anytime that you have something that's like a fraction, and if the whole fraction is raised to an exponent, just like when we did the last one, that exponent applies to everything in the problem. So it goes to everything in the numerator and everything in the denominator. So it's basically taking that exponent and distributing it in. But this time it's not just going to be maybe all single terms, like there's going to be this fraction part of it. Okay, so let's think about this here. Now be careful with this one because that negative sign is on the outside of the fraction. So really we can just kind of have that negative sign carry along and we can work with the two terms individually. So on the top, it's going to become 2 to the 5th power. On the bottom, you're going to still take your 3 times your 5. Because again, we took that 5 and we're distributing it in to our problem. What's 2 to the 5th power? 32. And the bottom, y to the, good, 15. And that negative is still sitting out front. Even if you had taken the negative and maybe applied it to the 2, then you would have gotten negative 32 because you would have had a negative 3 to the 5th power. So you're still going to get a negative answer here for your fraction. Questions on that one? Okay, so sometimes in problems, they're going to want you to use a couple of those different rules. Like sometimes you'll have to use the power of a powers rule, and then you have to use the product rule or the quotient rule, or you have to worry about the negative exponent. So there's going to be times where all of these things we've been talking about individually come together. When you're simplifying exponential expressions, you know you're done when there's no more parentheses in your problem. So all the parentheses have been taken care of and they're gone. The powers, like there's no powers raised to powers. Again, that would happen if there were parentheses happening. So if you haven't simplified that yet, you're not done. Each base only happens one time. So that means you don't have like multiple a's or multiple x's in your problem. And there should be no negative exponents and no zero exponents. Okay, so go ahead, if you haven't yet, take a minute and simplify that problem. So first thing I would have done is worked with my power of a power rule because I want to eventually get rid of those parentheses. So I took this negative 2 and I had to distribute it to the 5, to the x, and to the 4. So now I have 5 raised to the negative 2 power, x raised to the negative 2 power, and then y on the bottom here became negative 8. I see a lot of negative exponents, so I'm going to flip some things around. So what should I put on top now? What goes on top? Y to the 8th. And then on the bottom, the 5 and the x should go down. So it becomes 5 squared and x squared. What's the last thing I could do? Square the 5 and you get 25. Okay, I did it that way. That's not the only way you could have done it. If you had like a calculator, you could take 5 to the negative 2 power. Okay, but you're going to get a fraction or a decimal for an answer because it's trying to tell you that 25 needs to go in the bottom. So like your fraction would be 1 over 25 if you look at the fractional form of that. I'm not sure what the decimal would be off the top of my head, but it's trying to tell you like, hey, this number needs to go in the bottom of your fraction. If you move things around before you square it, then you don't have to worry about knowing where it's supposed to be. Okay, so with exponents, the last thing we need to talk about today is scientific notation, because in scientific notation, you are working with exponents. This would be when you're taking a number times 10 raised to a power. This is used especially when you're dealing with really, really large numbers or really, really small numbers. Instead of writing something out with a ton of decimals, we use scientific notation to simplify it. So let's just kind of practice first. If we were going to write something in scientific notation, maybe you guys remember, how would I rewrite this number here in scientific notation? Right now it's 5,210,000,000, but how would I write that in scientific notation? Does anyone remember?
5.21 times 10 to the 7th power, or the
7 or 9?
I'm not sure.
Well, how do you do it?
You count all the digits
You count all the digits, so you move the decimal all the way so it follows the first regular digit that's not a 0. So the 5. So it's how many? 9, because there's 3, 4, 5, 6, 7, 8, 9. Good. So 10 to the 9th power. What happens though on the second one?
Then you move it forward, so it'd be a -1.
Yeah, so you switch directions of your decimal moving, so it's going to cause your exponent to become negative instead of positive. So it's going to be 2.14. Again, we only move it until it has one digit in front of the decimal point. And how many times do we have to do that?
6 times.
6. So it'd be to the -6 power. Okay, so that's just reminding you how you write things in scientific notation, kind of the proper form for that. But now let's do some problems where we're operating with numbers in scientific notation. So the first thing is let's just multiply. When you're multiplying with scientific notation, some of those rules that we talked about still apply. The first thing I would do is just multiply 1.2 times 6.7. What does that come up to be? 8.04. Now with my tens, with your exponents, you're going to add them since they're the same base. So 5 plus 11 is 16. And so this is your answer. It's already in proper form. I don't have to worry about moving the decimal at all because it's following just the 8 and it's good to go. We're going to do the same thing with dividing. Same rules apply. What would be 5.3 divided by 4.1?
1.29.
Did you round that? Or did it come out to be 1.29?
I like rounded.
Okay, that's fine.
1.293.
Yep. So I would just round if you need to. And then times 10 to the what? -6. Good. And in this case, because it's scientific notation, you can leave that 10 to a negative power because this would be representing a really small number. Now, if I thought about this, this would be like 1 over 1.29 times 10 to the 6th power. That's still going to be really small. It's going to represent the same amount. Questions on scientific notation?